Somewhere in a lab in Shanghai, a woman known inside China's tech industry as the Chip Queen walked onto a stage and said something that should not have been possible. She said Huawei was going to build a chip as advanced as anything Taiwan or Korea can make today, without the one machine every single advanced chip on Earth depends on: no EUV. No ASML, not one of the tools the United States spent 6 years making sure Huawei could never touch again. And when she said it, the room did not laugh. Within hours, shares of China's biggest chip makers were up double digits, and the story was already moving faster than anyone could fact-check it. This is not a rumor from an anonymous forum. This is Huawei on the record, at one of the most important circuits conferences on the planet, claiming they found a way around the single biggest choke point in modern technology. And if what they showed is even half true, it changes who controls the next decade of computing. To understand why this is such a big deal, you need to understand the wall that Huawei has been slamming into since 2019. That is the year the United States effectively cut Huawei off from the global chip supply chain. Not just chips themselves, but the software used to design them and the machines used to manufacture them. The most important of those machines is called an EUV lithography system, built by a single company in the Netherlands, ASML, and it is the only tool in existence capable of carving transistors small enough to compete at the cutting edge. Without it, the assumption for years was simple: China is stuck. It can make decent chips. It cannot make great ones. Not because Chinese engineers weren't good enough, but because the physical tool required to shrink transistors below a certain size simply was not available to them, and building an equivalent from scratch was assumed to be a decade-long project at best. For a while, that assumption held. Then, in 2023, Huawei shocked the industry with the Mate 60 smartphone, a phone containing a chip more advanced than anyone believed China's domestic manufacturer, NSMIC, could produce under sanctions. It wasn't cutting edge by global standards, but it proved the wall had cracks in it. Washington's response was to tighten the restrictions even further, adding more entities to export blacklists and pressuring allied nations to close whatever loopholes remained. And for a couple of years, the story mostly stayed there. Huawei survives. Huawei improvises. Huawei stays a generation or two behind the true frontier, permanently playing catch-up. And now, in 2026, Huawei just walked back onto the stage with something far bigger than a surprising phone chip. They walked on with a completely different philosophy for how to build a chip in the first place, one that tries to make the EUV machine irrelevant rather than trying to build one. This announcement didn't come from a press release or a leaked internal memo. It came at the IEEE International Symposium on Circuits and Systems, one of the most respected engineering conferences in the world, held this year in Shanghai, in front of an audience of chip engineers who would immediately know if the underlying physics didn't add up. That venue matters. This wasn't a marketing stunt aimed at consumers. It was a technical claim aimed directly at the people most qualified to tear it apart. Here's the idea, and it's actually simple once you strip away the jargon. For more than 50 years, the entire semiconductor industry has followed one rule: make the transistors smaller. This is the famous Moore's Law, the idea that the number of transistors you can pack onto a chip doubles roughly every 2 years, because you keep shrinking each one. Smaller transistors switch faster, use less power, and let you cram more computing power into the same sliver of silicon. Every advanced chip on Earth, from the one in your phone to the one training the world's biggest AI models, exists because for decades, engineers kept finding ways to make things smaller. And to make things smaller today, at the frontier, you need EUV lithography. There is no substitute. That is the wall. Huawei's answer, unveiled by He Tingbo, the president of Huawei's semiconductor business, and the person Chinese media affectionately calls the Chip Queen, is to stop trying to win the smallness game entirely. Instead of asking how small can we make a transistor, Huawei is asking a completely different question. How fast can a signal travel from one point on a chip to another? They call this the tau scaling law, named after the Greek letter tau, which represents the time it takes an electrical signal to move through a circuit. Their argument is that if you can shrink that travel time, you get the same kind of performance leap you'd get from shrinking the transistor itself without ever needing the machine that shrinks transistors. The engineering behind this is called logic folding, and the concept is almost architectural rather than chemical. In a normal chip, circuits are laid out flat, like a single-story warehouse, with wires running long horizontal distances between different logic components. Long wires create something called capacitance, and capacitance creates delay. And delay is exactly the thing that limits how fast a chip can operate. Huawei's approach is to fold those flat circuits into compact three-dimensional blocks, essentially building upward instead of outward, stacking logic like a skyscraper instead of spreading it out like a warehouse. Shorter wires, less capacitance, faster signals, and crucially, none of it requires shrinking the transistor itself below what Chinese-made manufacturing equipment can already produce. Huawei claims this approach delivers a 55% increase in transistor density compared to a conventional flat layout built on the exact same manufacturing node. To put that in real numbers, Huawei's current Kirin 93rd chip, built on domestic manufacturing technology roughly equivalent to what the industry calls 7 nanometers, packs around 155 million transistors into every square millimeter. Huawei says its upcoming Kirin chip, using logic folding on that same manufacturing process, will reach approximately 238 million transistors per square millimeter. According to analysis from the semiconductor research firm TrendForce, that would put Huawei's new chip in the same density range as TSMC's first generation of 3 nanometer chips, a Taiwanese manufacturing process so advanced it is currently completely out of reach for any Chinese factory. And here is the number that should genuinely stop you. Huawei says this entire architecture is not some hastily assembled announcement rushed out for a headline. Tingbo revealed that the company has been quietly developing logic folding for more than 6 years, and in that time, in near total secrecy, Huawei has already designed and physically produced 381 different chips using this method, just to validate that the underlying engineering actually works. This wasn't a slide deck. This was 6 years of silent, expensive, real-world testing hidden from the public the entire time Huawei was supposedly locked out of advanced chip making. The commercial target for all of this arrives sooner than most people expect. Huawei says the very first chip using logic folding will ship this autumn inside its new flagship Kirin processor, expected to power the next generation of Huawei's Mate smartphone line. Huawei's specific performance claims for that first chip include a 41% improvement in energy efficiency for its performance cores, a 12.7% boost in peak clock speed up to 1 gigahertz, and that 55% jump in transistor density. If those numbers hold up once independent labs get their hands on the actual hardware, it validates the entire thesis in the real world instead of just on a stage in Shanghai. But the smartphone chip is really just the opening move. Tingbo said explicitly that the real prize is not your next phone, it's artificial intelligence. Huawei plans to bring the Tau scaling law and logic folding architecture into its Ascend line of AI processors, the chips designed to compete directly with NVIDIA inside massive AI data centers, with that transition targeted by around 2030. And this is where the story stops being about smartphones and starts being about the global AI arms race. Because in AI computing, the biggest bottleneck often isn't raw math. It's moving data around, shuffling information between the processor and memory fast enough to keep up with billions of calculations per second. Engineers call this the memory wall, and shrinking tau, that signal travel time, attacks exactly that problem. If Huawei can fold AI chip logic the same way it's folding smartphone chip logic, the efficiency gains could matter even more inside a data center than inside your pocket. This isn't theoretical either. Huawei's current Ascend 950PR chip, built without any of this new architecture, is already delivering around 1.5 petaflops of AI inference performance, and, according to reports, roughly 2.8 times the low-precision throughput of NVIDIA's H20, which is currently the most powerful NVIDIA chip Chinese companies are still legally allowed to buy. Chinese tech giant ByteDance alone reportedly invested $5.6 billion into Ascend chips this year. And total demand across Chinese hyperscalers for Ascend hardware is estimated between $12 and $15 billion. That is real money from real companies, betting on Huawei Silicon right now before logic folding has even entered the AI chip line. Huawei's ultimate target, and this is the number that genuinely rattled analysts, is transistor density equivalent to a 1.4 nanometer manufacturing process by 2031. For context, TSMC, the world's most advanced chip maker, is targeting mass production at that exact 1.4 nanometer node in 2028. If Huawei's timeline holds, a company that was supposedly locked out of advanced chip making entirely would be closing in on the global frontier within just a few years of the world leader, using a completely different engineering path to get there. The market reaction? The moment this was announced tells you how seriously investors are taking it. Shares of semiconductor manufacturing. International Corporation, China's largest domestic chip fabricator and the company that would actually manufacture these Huawei-designed chips, jumped more than 19% in a single day of trading in Hong Kong. Hua Hong Semiconductor, another major Chinese chip fabricator, rose more than 16%. On Chinese social media, a hashtag translating roughly to Huawei Semiconductor field new breakthrough generated more than 40 million views within days, with commenters comparing it to the so-called DeepSeek moment, referring to when a Chinese AI startup shocked Silicon Valley last year by matching top American AI models at a fraction of the training cost. People are now openly asking whether this is the DeepSeek moment for chips. It's worth pausing on who actually delivered this news, because the framing mattered almost as much as the technology itself. Tingbo has become something of a symbol inside China's tech industry, nicknamed the Chip Queen. And some commentators on Chinese social media have even taken to calling this breakthrough Her's Law, a play on her name standing in place of Moore's. During her keynote, she reportedly reflected on just how difficult the last several years have been for Huawei's semiconductor division, operating under a sanctions regime that many industry observers assumed would permanently box the company out of advanced chipmaking. The message wasn't just a technical one, it was a narrative one, aimed at an audience that has spent years being told there was no way through. Now, before you assume this is a done deal, it's worth being honest about the skepticism, because there is real skepticism, and it matters. Huawei did not release independent third-party performance data alongside this announcement. Every number you just heard came directly from Huawei itself. Analysts at firms like Omdia have publicly said it remains genuinely uncertain whether Huawei can actually deliver on this roadmap, calling it an alternative path forward rather than a guaranteed win. And there is a deeper physical challenge that logic folding does not magically erase. Stacking circuits in 3 dimensions creates serious heat problems, because you're concentrating more transistors and more power draw into a smaller physical space with less surface area to dissipate that heat. Managing thermal output in a densely folded 3-dimensional chip is an entirely different engineering battle than managing heat in a flat one, and Huawei has not fully detailed how it plans to solve that at scale. There's also the question of yield, meaning how many of these complex folded 3-dimensional chips actually come off the production line working correctly versus how many are defective. Advanced manufacturing already struggles with yield at flat 2-dimensional designs. Folding logic into vertical stacks multiplies the number of things that can go wrong during fabrication. Huawei says its 381 prototype chips over 6 years prove the concept works. But proving a concept works in a lab is a very different achievement than proving it can be mass-produced at the volume needed to actually supply hundreds of millions of smartphones and thousands of AI data center racks. One analyst, quoted by the Wall Street Journal from the research firm Omdia, put it about as fairly as anyone has. It remains to be seen whether Huawei can really deliver on this at scale, but regardless of the final outcome, it represents a genuine alternative path forward, one Huawei found specifically because it was locked out of the conventional route everyone else was using. That's a careful, measured way of saying, don't assume this is vaporware, but don't assume it's a done deal either. It's also worth sitting with just how unusual the broader moment is. This announcement didn't happen in a vacuum. Chinese chip exports were already surging heading into this year, reportedly up around 100% year over year by this spring, roughly tripling over the prior 2 years. Analysts at Goldman Sachs have noted that semiconductors, computers, and other AI-related products made up about half of China's total export growth in recent months. Whatever you think of Huawei's specific claims, they are landing inside a Chinese tech sector that is already moving with real momentum, not one desperately grasping for a headline to distract from decline. That context matters, because it changes how much weight the rest of the industry is willing to put on Huawei's word. And timeline skepticism deserves its own moment here too. The headline target, that 1.4 nanometer equivalent density, is not landing until 2031. Even the most optimistic outside estimates suggest meaningful production volume of these next-generation chips probably doesn't arrive until 2028 or 2029 at the very earliest. That means for the next few years, this remains largely a roadmap and a promise, not a shipping product at scale. The real proving ground is actually much closer than 2031. It's this autumn when the very first logic folding chip lands inside Huawei's new Kirin processor. That's the moment independent labs, reviewers, and rival engineers finally get to tear the chip apart and check whether Huawei's numbers hold up under real scrutiny or whether this was more marketing than materials science. Here's why all of this matters even if you have never bought a Huawei phone and never will. If Huawei's approach genuinely works, it does something the sanctions regime was specifically designed to prevent. It breaks the assumption that controlling one machine, EUV lithography, means controlling the ceiling of what China's semiconductor industry can achieve. For years, the entire strategy out of Washington rested on the idea that you don't need to police every part of the chip industry if you control the single choke point that makes the most advanced chips physically possible. Huawei's bet is that you can build your way around that choke point with smarter architecture instead of smaller transistors. And if that bet pays off, even partially, it means the leverage the United States built over years of export controls starts eroding, not because the controls failed, but because the target found a different route entirely. There's a bigger ripple effect, too, one that reaches NVIDIA, TSMC, and every Western company that assumed China was years, maybe a decade, away from serious competition at the high end. If Huawei's Ascend AI chips actually adopt this architecture by 2030 and deliver real efficiency gains, Chinese cloud providers could offer AI computing power at meaningfully lower cost because their underlying silicon would be cheaper and less dependent on components the West controls. That kind of pricing pressure doesn't stay contained inside China. It pushes against the pricing and margins of every company selling AI computing power globally, whether or not a single Western company ever buys a Huawei chip directly. It also reframes what export controls are actually capable of achieving in the long run. The entire strategy behind restricting EUV access was never really about permanently stopping China from making advanced chips. It was about buying time, slowing the pace of Chinese progress long enough for the rest of the world to keep extending its own lead. Huawei's Tau scaling law doesn't disprove that strategy worked for a while. If anything, it's a direct product of that strategy. 6 years of forced improvisation because the conventional path was blocked. What it does suggest is that the time being bought may be running shorter than planners in Washington originally assumed, because the constraint didn't stop Huawei's engineers. It just redirected them toward a problem nobody else was seriously trying to solve, since everyone else still had access to the tools that made solving it unnecessary. There's also a quieter irony worth noticing here. Every major chipmaker that does have access to EUV lithography, NVIDIA's partners at TSMC, Samsung, Intel, has essentially had no incentive to explore an alternative to shrinking transistors, because shrinking transistors has always worked and the machines to do it, while extraordinarily expensive, are available to them. Huawei didn't stumble into logic folding because it was a better idea sitting on a shelf waiting to be picked up. It built logic folding because the usual toolbox was taken away, and necessity forced its engineers to ask a question the rest of the industry had far less reason to ask. Whether that turns out to be a temporary detour or a genuinely superior long-term path for the entire industry, sanctions or no sanctions, is a question even Huawei's rivals are now reportedly taking seriously enough to study. It's worth remembering just how far Huawei's AI hardware ambitions have already come without any of this new architecture. Last September, the company laid out a 3-year roadmap specifically for building AI chips, a plan explicitly designed to fill the gap left inside China after NVIDIA was largely shut out of the Chinese market by its own government's export rules. Chinese hyperscalers didn't wait around to see if that roadmap would pan out. They started buying Ascend chips at serious volume, which is exactly why you're seeing numbers like ByteDance's multi-billion-dollar order sitting on the books already. Logic folding isn't Huawei's first move in this race. It's the move that could turn an already growing domestic alternative into something with genuine international pull. So where does this actually leave us? Huawei has not built the impossible chip yet. What Huawei has built is a credible, 6 years in the making argument that the impossible chip is reachable through an entirely different door than the one the world has been watching. The first real test of whether that argument survives contact with reality comes this autumn in a smartphone sitting in someone's pocket. The bigger test, the one that actually reshapes the global AI race, comes by the end of this decade, when the same architecture is supposed to show up inside the machines training the world's most powerful AI systems. Nobody outside Huawei knows for certain yet whether the physics, the heat, and the manufacturing yield will cooperate at the scale this roadmap demands. But the wall that was supposed to keep China permanently behind just got a very serious crack in it, and every major chipmaker on Earth is now watching to see how deep that crack actually goes. If this story matters to you, hit follow so you don't miss what happens when Huawei's first logic folding chip actually ships this autumn.